Hey guys, how's it going? Um, Today I want to talk about section 3.6, which is solving compound inequalities. Compound inequalities are basically just when we have multiple greater than or less than going on in one situation. So basically, for example, this is really what we're going on. Compound inequalities. So if I were to say on the last quiz, everyone scored above a 70 and below a 95. So we have basically two things going on. Basically, we said everybody is above a 70, so x would be greater than 70. And this is an important part, we're going to talk about that more in a second, and below a 95, which means basically x was less than a 95 as well. Notice I did not put or equal to in either one because this says that it was strictly above 70 and it was strictly below a 95. Now, this is one way we could write this compound inequality. We could write it as two different. But we also like a little bit of a shorthand note where we can basically put the x in the middle. Okay? Anytime we're doing an and, especially, we can write it as a compound inequality, meaning we have two different inequalities going at the same time. If you write this way, basically we put this one backwards. We're going to say x has to be greater than 70, so we're going to write it this way. So this basically, if I read it from the x, it's x is greater than 70. And we also can say, if we read it from this way, x is less than 95, okay? So if we basically write them this way, it means the same thing as this. So this basically means x has to be greater than 70 and it has to be less than 95, or basically between, okay? Now, with compound inequalities, we have basically, sometimes we're going to deal with and, sometimes we're going to deal with or. And there's a big difference between and or. I mean, we already know the difference between and or, but in math, it's very, very specific. And is what we call the intersection, okay? So let's take an example here. We have situation A, which is x is less than 10. So in x is less than 10, we have numbers, all kinds of crazy numbers, like negative 100 and negative 50 and negative 2, right? But we also have numbers like 8 and 2. Those numbers are all less than 10. Now we also have a different situation where x is greater than 0. Well, 2 is greater than 0, 8 is greater than 0, okay? But numbers like with numbers like 15 or 25 or 823, these numbers are also greater than 0 as well. But for the and portion, we're only going to look for numbers that satisfy both situations, where we're in both circles, okay? So the and is what we call the intersection. Basically, where do those two collide? Graphically, it looks like this. We have situation A, where it's all the numbers less than 10, and there's lots of them. And then numbers in situation B, we had numbers greater than 0. Well, the intersection would be, where do they overlap? Where are both situations true? So now we're only between the 0 and the 10, okay? Now, that's different than the or. Okay? The or is what we call the union, okay? Basically, if I hit either circle, then I'm satisfied, okay? It's not where they overlap. It's basically I can hit either or, okay? I like to think of it like throwing darts. If I had this drawing and I said, if I throw a dart, and I have to hit and A and B, well, that means I have to hit in this little area here. But if I use the word or, if I, throw a dart, what's the probability, or what's the, I can satisfy it hitting A or B. Basically, I could hit anywhere in the first circle or anywhere in the second circle, and I'd be good. Now, graphically, situation, now we're dealing with x is less than 0, so we're over here. Anything to the left is 0. X is greater than 10, so now we're over here. Or we don't have a shortcut way like this one over here, but this is the and. These are only used for ands. Or we do have to write it as two different inequalities because they are two different situations. Basically, it'd be anything over here or anything over here would work, nothing in the middle, okay? So it is very important to notice and determine, are we dealing with an and situation or an or, okay? This kind of notation is only used for and situations, okay? If it's an or, you have to write them separately, okay? Now, we're going to run into some problems that kind of look like this. This is definitely an and situation, okay? I know that because it's written in the shorthand notation. This means the same thing as basically x plus 2 has to be greater than or equal to 4, so we could write it like this, and x plus 2 is less than or equal to 8, okay? These two things right here, this and this, mean the exact same thing, okay? I knew it was an and because it was written like this. Now, to solve them, you can solve them separately if you want to, or basically we can solve two equations at the same time. Basically, how do I get the x by itself? I want a minus 2. But if I minus 2 from here, I have to minus 2 from here, and now I'm also going to minus 2 from over here, okay? Basically, what I'm going to do is I'm going to solve two different inequalities at the same time. So here I get the x by itself. I'm minusing, so I'm not going to flip signs over, okay? By the way, the signs are always going to be faced this way for ands, because you always like to put the smaller number on the left. 4 minus 2 would be 2. 8 minus 2 would be 6. And we'd be done, okay? So basically what we're going to do is we're just going to solve two different inequalities at the same time. We'd get x is greater than or equal to 2 when we minus 2. Oh, and minus 2 over here, we'd get x is less than or equal to 6. These two things are the same thing. You can solve them separately if you want to, or at one time. I think at one time is the easiest thing. So kind of think of it this way. I want to get the x by itself. Well, first thing I'd want to do in here to get the x by itself is to minus 3. But if I minus 3 from here, I have to minus 3 from here, and I have to minus 3 from here. Okay? So here I'd get negative 8. Leave that sign. Here I just have 2x. Leave that sign. Notice you can have or equal to and not or equal to, okay, in the same compound inequality. Okay, now I want to get the x by itself, so I'm going to divide by 2, which means I got to divide this by 2, and I got to divide this by 2. Okay. So here I'd have an x. X has to be greater than or equal to negative 4 and less than 3. Okay? And then graphically what this would look like is basically I'd have a 3 over here. I'd have a negative 4 over here. I'd have a closed circle at negative 4, because it's or equal to. I'd have an open circle at 3, and I would be shading in between those two numbers. And is in between. Okay? It's simple enough. When you run into or problems, well, they're always going to be written as two different. Sometimes they're the same, sometimes they're not. In this case, I want to get the x by itself, so I'm going to add 4. Well, I'd be left with x is greater than 5. Or, over here, I'd again want to add 4, but I'd have to add 4 over here, and I'd get x is less than 1. So graphically, I'd have a 1, I'd have a 5, they'd both be open circles. X is greater than 5 means it's got to be over here to the right of 5. X is less than 1, which means it's left of the 1. So, or I'm either or. Okay? Now, sometimes they don't have to be exactly the same. But again, we just solve them separately. This one I'd want to divide by 7. So I'd get X is greater than or equal to 3. This one I'd want to divide by 2. So I get X is less than -1. Again, graphically, I'd have a -1. I'd have a 3. I would have a closed circle at 3. This is X is greater than or equal to 3, so to the right of that. I'd have an open circle at -1. X is less than -1. So again, we're shading to the left of there. So they'd be going away from each other. Ors are typically always going away from each other. Okay? That's really about it, guys. So try a few of these. Again, make sure you really understand the difference between and or. That's really the biggest thing out of this section. But try some of these and let me know how it goes. Okay? I'll talk to you guys later.